Hello, guys. All right, good to be back. I was talking to a friend very recently, and we were discussing on a subject that we actually published on Altryton Automotive Pub very recently, where we were discussing about the kinds of fuel that actually is recommended by your manufacturer for your car to work more efficiently. And it was asking why do we even have different octane ratings for the kind of petrol that we use for our cars. So invariably, that's as good as asking the question, why does petrol have different grades? Why would we have to be very concerned about the kind of octane number, kind of fuel that we use for our vehicles? And now, if you've missed it, we had two videos in the past where we discussed the significance of octane rating, the importance of the term knocking, and how that impacts on your engine performance, and how using a bad fuel can actually damage your engine. All of that has been discussed in some of the videos that you can check on our page, and you'll find out a very clear, simple, and easy to understand explanation on those concepts. So now, to answer the question, why do we have different grades of petrol? Why do we have, when we talk about grades of petrol, it simply means petrol with different octane number. And remember, just to recap, we said octane number actually measures, is like something that measures how quickly your fuel burns in your engine. So it is rated with a metric called the octane number rating for petrols. So the higher the octane number, the more compression it requires to burn the fuel in the combustion chamber of your vehicle engine. The lesser the octane number, the quicker it ignites and the quicker it burns. So, for example, very quick example, if I'm using a vehicle and it requires an octane number of say 94, and I put a petrol in the vehicle that has an octane number of say 80, what's going to happen is going to be very, very disastrous, and it's going to be unhealthy for your engine. What that simply means is you are using a petrol that has a lower octane number than what your manufacturer for that vehicle has designed. And what will happen is pre-ignition of fuel. Fuel that is supposed to ignite at an octane number of say 94, you put one that is 80. So before it gets to that value, when you are compressing in the engine, it ignites. So premature ignition can damage the engine. This is what we've explained in the previous video before. So, but why do we have different grades of petrol? In the markets, different grades of petrol is only available because the refineries that process them actually are listening to engine manufacturers, because most of the petroleum products we use actually are fuels. They serve as fuels to engines, internal combustion engines. So if I'm producing the petrol for my refinery, if I have a refinery, I'm going to produce petrol for the general market, I should be asking the manufacturers who design engines that are going to use these fuels, what kind of fuels do you want? So manufacturers are beginning to see advancements in technology, and they are pushing the limits in the design of engines. And what that simply means is that people are beginning to require engines that need higher compression ratios. And as a result, lower octane kinds of fuel are not going to function effectively for those kinds of engines. So what they do is they are designing higher compression, higher efficiency engines, and that require higher performance. And those performance can only be possible when you use high quality kinds of petrol. And that's why you hear of PMS, premium motor spirit. It's also like fuel. It's also fuel in itself. It's also the petrol that you know. However, the octane number is higher. They have higher quality, and the truth is, not every vehicle uses premium motor spirits, needs premium fuel to run. And why that is so is what I'm going to explain in some minutes. So as the advancement in technology continues to increase, manufacturers are saying, okay, I need to build engines that are faster, that can deliver more power, even as lesser size of engines. And to do that, they are increasing the compression ratio. That's what is more important in the design of engine, compression ratio. Now, if you're an engineer, you know how significant compression ratio is in improving the power and efficiency of an engine. But let's not go engineering. Let's make it basic. If they are designing engines that have higher compression ratios, meaning you can squeeze fuel more to get more power or the same volume of fuel. For example, I have a car A that is made by a different manufacturer, and that car is small, and the fuel, let's say it's a 1.8 liter engine, but the compression ratio of that engine is say 11:1, for example. So what that means is that engine is going to squeeze for 11 times more. If I have another vehicle, the same volume of 1.8 liter, if I have the same kind of vehicle from another manufacturer, the same engine size, 1.8 liter engine, but the compression ratio is, let's say, 8:1. The same volume of fuel, however, one is going to generate more power than the other. The simple reason is because the compression ratio of one is better than the other. So those two uses petrol. They use 1.8 liter of petrol. However, the grades of petrol you use for those two engines are entirely different. If you are using the same grade of petrol for both of them, one of them is going to misbehave. The reason is because one needs to squeeze the fuel so much to get as much power from it. So if you use a lower quality petrol in an engine that requires more compression, pre-ignition will happen. Knocking that we talked about is going to happen, and it can cause damage to your engine. So manufacturers just want to deliver more power in the vehicles that they are designing, and that is why they are asking refinery operators to process fuels that have higher octane number, that are more efficient, and that meets with standards. So that is one reason why we have different grades of fuel in the market, and that really explains a lot of things. For those in the Western nations, I beg your pardon. For those in the Western nations, they go to the retail outlets or the filling stations, and you see right at the pump, you see different variants of petrol. The same petrol, but you see different octane number. You see some 89, 90, 94. What that simply means is that they are all petrol, but different grades, different quality, depends on what you want. How you know what grade is meant for your car has been discussed in a previous post. You could just check our page and you find out for yourself. So this is why we have difference in the grades of petrol that we buy, or that is available in the market, or that manufacturers that runs refinery actually produce. And I just remembered also, beyond getting more power from the engines, manufacturers too are very much concerned about environmental protection. You see, this is why engineering is beautiful. People are constantly thinking about ways to design engines that are more environmentally friendly, that are more sustainable, that support sustainable development goals. And this is why engineers are becoming much more creative. You see, if you've read about environmental protection standards and all of the codes that govern emissions, there are now stricter laws involving emissions that comes out from internal combustion engine, either from cars or from any other equipment that uses an engine. So what manufacturers are also doing in order to meet up with such regulations is to ensure that the fuels that are burnt in their engines try as much as possible to burn completely. And this is why people are increasing compression ratios, like we said before. So if you increase compression ratios, it makes sure that the fuel burns nearly completely in the engine, and what comes out is just a little or very, very, very small amount of incompletely burnt fuel. So that already reduces the carbon footprint that those engines made by those manufacturers actually release to the environment. So you see, all of this adds up. So while you cannot entirely eradicate old engines, newer engines are pushing the limit. Newer engines are requiring much more advanced kinds of fuels, much more efficient fuels, and the octane numbers are higher, the grades are better, they are more premium and even high quality petrol in the market. So in nations where they may not use much of premium motor spirit, it's simply because they still have lots of old cars driving there. But in countries or in nations where you have modern vehicles, fairly new cars, they use much more high performance petrol, and they use petrols with higher octane numbers. So what's the key takeaway? So what we've discussed so far is that manufacturers are actually raising the bar when it comes to the kinds of fuels that are available in the market and that they can apply to their kinds of vehicles. And as such, it's only to help, one, drive more power that comes from engines that retain the same kinds of fuel volume and even the same size of engines, but to deliver more power. And also, in the course of delivering more power, they also help to compensate in how they comply with environmental laws regarding emissions, so that the more you burn the fuels, you reduce the amount of carbon footprint that your engine contributes in the entire world. So this is the reason why we have different fuel grades, different fuel qualities, and this is why engineering is pushing itself forward. So I hope this is clear, and I hope you got the point. So when you go to your nearest filling station, the next thing you should be thinking of is, what kind of fuel does my car use? What is the octane number my car requires? If you don't know, check, find out. so like I'm using the right fuel for the right car. But the next question that remains is, if we say premium motor spirits, premium fuel are actually better, should I not use premium fuel in my car? Why am I using a regular kind of petrol? Does premium fuel means more power or more efficiency? We'll discuss that in the next article. See you in the next one.